What up, everybody? InstructaBeats back again here with our statistics unit. Today we're going to be showing numerical data using a histogram. So our objective today I will be able to represent the data collected visually by using a histogram, just like the title of our lesson. So last lesson we started looking at visual models. We start with the dot plot, which used dots to represent the frequency in which the data shows up, and it was really good for small sets of data and showing groups and outliers. Our new visual model we're going to be doing today is called the histogram, and it is a visual model that is going to use bars to show frequency of data by grouping data into intervals, which we call bins. Now that's a lot of words, it might be confusing, but I promise you it's very easy and we'll show you some examples. Just go ahead and get that down in your notes. And it's really good for visually seeing patterns of large groups of data without looking at each individual data point. So what you're doing with a histogram, and it's going to look like a bar graph when you see it, but it's not a bar graph, okay? I promise you that, just very similar. We're going to be grouping data together so that way we can look at large groups of data. So the dot plot was good for small groups of data. You're going to use a histogram if you collected a lot of data. So let's say we asked that stuffed animal question to 1,000 people. That would be a really good set of data to make a histogram with and not a dot plot, because you don't want to have 1,000 dots on your number line. Let's take a look at making a histogram with our stuffed animal question. Now, this is a terrible set of data to make a histogram with, again, because this is really good for large pieces of data, but we're going to do it that way you can kind of compare the dot plot and the histogram, and our next visual model we'll be talking about next lesson with the same question. So a histogram is going to have an X and a Y axis, but typically in a histogram, you're not going to show each individual piece of data. You're going to be grouping them together. And so what you want to do is you want to put them into bins. That's what they're called. So we're going to first start by kind of putting these into bins, kind of like you're putting your laundry into a bin. And we don't really have a large group of data, and it's not a wide range, right? But we're going to do our best with it. Our first bin is going to be from 0 to 2. Stuffed animals. Our second bin would be from 3 to 5 stuffed animals, and our last bin is going to be from 6 to 8 stuffed animals. Now, in a histogram, you don't have to make the bins even, but then it becomes a little bit more confusing and a little bit more complicated. So if you keep your bins the same, meaning that you have 3 different options for each of them, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, then it makes it a little bit easier to make and interpret these histograms. In my 0 to 2 bin, right, I had a 0, a 1, a 2, a 2, and a 2, right? So I had a 0, I had a 1, I had a 2, and a 2. So I have 5 different numbers that are in my 0 to 2 bin. Let me cross them out here. In my 3 to 5 bin, I have just a 4 and a 5. So I only had 2 numbers that were grouped together in that bin. It's kind of like doing your laundry, right? You do maybe put all your reds together, all your blues together, and all your greens together. And then in the last one, we had a 6, a 7, and an 8. So I'm going to group these together in those bins. So just like on our dot plot, we're going to make this into a number line. So here we have 0, then we have 1, 2, 3, 4, 5, 6, 7, and 8. And this is where it kind of looks like a bar graph, but I'll explain the difference in a second. So our first bin was from 0 to 2. Okay, so our first bin is going to go from 0 to 2. And in that bin, we saw that number group 1, 2, 3, 4, 5 different times. Oh, I need to probably label my y-axis as well. There we go. I'll go up to 5. And so from 0 to 2, we saw we saw those numbers 5 times. So my first bin from 0 to 2 had a frequency of 5. There are 5 different values that fell into that bin. My next one I'm going to make red was from 3, okay, to 5 right here. And we have only had 2 instances where that was together. So I'm going to go up to 2, and I'll put those dots right there. And in that bin, there were only 2 times that those values were seen. And so here's the thing about the histogram. You don't know if the 4 was seen twice. You don't know if the 5 was seen twice or the 3 was seen twice. You just know that in this bin, the frequency was 2. It happened twice. And then my last one, I'll make green. In my bin from 6 to 8 that I made, there were 3 different numbers that fell into that bin. So I'm going to go to 3. There we go. And I'm going to shade this bin in. And this is why people get it confused with a bar graph. There we go. Because it kind of looks like a bar graph. The difference is that bar graphs are used to compare different variables. So how many people like popcorn versus how many people like pizza versus how many people like hot dogs, right? You're comparing three different variables there. A histogram is used to show the distribution or the spread of the data, right? There's only one variable here, the amount of stuffed animals you had. And this histogram is showing us, okay, well, from 0 to 2 stuffed animals, there are 5 people that had that many stuffed animals. There are 2 people that had 3 to 5, and there was 3 people that had 6 to 8 stuffed animals. So most of the people had 0 to 2 stuffed animals, right? You can make that inference, that conclusion very quickly by looking at the histogram. Again, a bar graph is going to compare different variables. A histogram is just going to show the distribution of the data for one variable. Let's do a U-try problem. So here our U-try problem says the data below shows the data collected to answer the question, how old are the teachers at your school? Take the frequency table and make a histogram to visually represent the data. So here they gave you the intervals, or what we call bins, already. So from 20 to 30 years old, there was 5 people in that age group. From 30 to 40, there were 12. From 40 to 50, there were 11. From 50 to 60, there were 7. From 60 to 70, there were 1. And from 70 to 80, there were also 1. So they've given you the bins, the intervals already. You just have to put them on your histogram. So go ahead and push pause. Try to make it. If you're confused, that's all right. Just wait till I go over it. If not, push pause. Do your work right now, and then you can check your understanding. So hopefully you just paused it. So the first thing I'm going to do is I'm going to make my bins. So I know my first bin is from 20 to 30. There we go. And then I had 40. I'm counting by tens here. 50, 60, 70. Ooh, let me just move this over here. 70, and then we had 80 right here. So for this, I'm actually going to count by 2. So we're going to have 2, 4, 6, 8, 10, 12 here. Okay, and so my first bin for the age group from 20 to 30, I had 5. So 5 would be halfway between 4 and 6. And so my first bin right there, I had 5 teachers who fell into the group from 20 to 30. Now from 30 to 40, that was the biggest group. That was all the way up to 12. So I'll do that right there. Put that right there. See if I can make this as straight as possible. There we go. Doing my best. All right. There we go. And I can see that that bin is actually quite large. There's a lot of teachers in that 30 to 40-year-old range. Now, some of you might be saying, okay, well, it goes 20 to 30 and then 30 to 40. What happens if you're 30? Well, if you're 30, you're going to go into the next bin, right? So if you're right on the edge, you would put them in the next bin. So if someone said, hey, I'm 30 years old, they would go in from the 30 to 40-year-old bin, okay? And that's typically the general rule for histograms. So in the 40 to 50-year-old bin, we had 11. So 11 is halfway between 10 and 12. Got to speak proper English. There we go. And I'll just kind of shade that in, although you don't really need to shade it in. Kind of makes it more confusing. From 50 to 60, we dropped down to 7 teachers, okay? And again, you could have been 50, you could have been 51, 52, 53, 54, 55, 56, 57, 58, 59. And then if you were 60, you'd go to the next bin. So the next bin only had 1 teacher who was that old. And then my last bin, also from 70 to 80 years old, also only had 1. So now I can look at this histogram and I can make some pretty good conclusions based on just looking at the dispersion of data. Most teachers are from 30 to 60 years old. Actually, most teachers are from 30 to 50, and then after 50, it kind of slowly dwindled down. So you can make the assumption that most teachers are either quitting or retiring before they turn 60 years old, because after 60, there is only 2 teachers if you count both of these bins together. All right. You can also see that from 20 to 30, there wasn't as many. You can see that this is really grouped around that 30 to 50-year-old range, and that's where the chunk of the teachers in your school are. That's how old they are. So histogram is really good at looking at large pieces of data, because if you look at this, there were about 37 teachers that answered this question when you collected the data. You wouldn't want to have 37 dots on a dot plot, right? So this is a really good way to group them together and easily make assumptions based on the large pieces of data that you're collecting. Thank you so much for checking us out. We really appreciate it. We'd love for you to comment, like, and subscribe. Join our InstructaBeats family. You can follow us on all the social media accounts. We'd love to have you follow us on there. Again, thank you so much. InstructaBeats out.